The idea of infinity is one of the oldest and most mysterious concepts ever created by the human mind. Long before modern science, advanced mathematics, or telescopes that could observe distant galaxies, humans were already thinking about things that seemed endless. Infinity did not begin as a scientific discovery. It began as a psychological experience. Early humans looked at the sky, the horizon, the ocean, and the repeating cycles of nature, and felt confronted by something that appeared to have no boundary. This feeling of endlessness planted the first seeds of the human idea of infinity. Human perception naturally seeks limits. We understand objects by measuring them, comparing them, and defining where they begin and end. A tree has a height, a river has a length, and a day has a duration. But certain experiences resist these limits. When ancient people stared at the night sky, filled with countless stars, they could not easily imagine where it stopped. The sky seemed boundless. Even today, when we know much more about astronomy, the emotional impression remains the same. Infinity first entered human thought not as a number, but as a feeling, the feeling of confronting something larger than comprehension. Early civilizations attempted to explain this sense of endlessness through mythology and religion. Many cultures described eternal gods, endless heavens, or cycles of creation that never truly ended. These stories were not mathematical explanations, but symbolic attempts to express infinity using narrative. Eternity became associated with divine power because only something beyond human limitation could exist forever. The human idea of infinity was therefore deeply connected to spirituality, long before it became connected to logic. Ancient philosophers were among the first to analyze infinity intellectually. Greek thinkers, especially, struggled with whether infinity could exist in reality or only in thought. Some philosophers argued that infinity was impossible because everything real must be complete and defined. Others believed infinity existed as a process rather than an object. This distinction became extremely important. Infinity was not seen as something you could reach, but something you could approach endlessly. One of the earliest philosophical challenges came from paradoxes, designed to show how confusing infinity could be. Consider the idea of dividing distance into smaller and smaller parts. If a runner must first travel half the distance to a finish line, then half of the remaining distance, and then half of the remaining distance, and then half again forever, it seems logically impossible for the runner to ever arrive. Yet in reality, runners clearly reach their destinations. These paradoxes revealed a tension between logical reasoning and physical experience. Infinity seemed both necessary and problematic at the same time. The human brain evolved to survive in a finite world. Our senses are adapted to handle manageable quantities, dozens, hundreds, perhaps thousands. But infinity goes beyond any scale. The brain evolved to process. Cognitive scientists suggest that infinity feels strange because it exceeds intuitive reasoning. We can imagine very large numbers, but we cannot truly visualize endlessness. Instead, the mind substitutes infinity with the idea of continuing forever, which is a process rather than a completed image. Language also shaped how humans understood infinity. Words like forever, endless, and eternal appeared in nearly every culture. These words did not describe measurable realities, but emotional and philosophical ideas. Poetry, religion, and storytelling allowed people to engage with infinity without needing precise definitions. In this way, infinity became both a linguistic and cultural invention, a concept shared collectively even though no one could directly experience it. As civilizations advanced, counting systems expanded human awareness of numerical growth. Early counting often stopped at practical limits related to trade or agriculture. However, once societies developed abstract mathematics, people realized numbers never truly end. After 10 comes 11, then 12, then 100, then 1,000, then 1,000, and so on without limit. This realization marked a major turning point. Infinity shifted from being only a spiritual or philosophical idea into a logical necessity within mathematics. Yet even then, infinity was treated cautiously. Many ancient mathematicians avoided using it directly because it seemed dangerous or contradictory. Instead, they described quantities as becoming larger without bound. This phrasing avoided claiming infinity as a completed thing. The hesitation reflected a deep discomfort. Infinity challenged the belief that reality must be orderly and understandable. The human fascination with infinity also arises from self-awareness. Humans uniquely understand that life is finite. Awareness of death naturally leads to thoughts about eternity. People imagine infinite time, partly because they recognize their own limited lifespan. Infinity becomes a contrast to mortality, a way to think beyond personal existence. Philosophers have long argued that the concept of infinity may emerge directly from humanity's confrontation with finiteness. Art and architecture also reveal humanity's engagement with infinity. Repeating patterns, symmetrical designs, and endless geometric motifs appear across cultures. These designs visually suggest continuation beyond boundaries. Islamic geometric art, for example, often uses repeating structures that appear capable of extending forever, symbolizing unity and the infinite nature of creation. Such artistic expressions show that infinity is not only intellectual, but aesthetic. Humans find beauty in patterns that imply endlessness. Another important aspect of the human idea of infinity is imagination. Unlike physical perception, imagination has no clear boundary. People can imagine adding another star to the sky or another number to a sequence endlessly. This mental freedom makes infinity feel natural within thought, even if it remains unreachable in reality. The mind experiences infinity as possibility rather than completion. Children provide an interesting example of how the concept develops. When young children first learn numbers, they often believe there must be a largest number. Eventually, they discover that numbers continue indefinitely. This moment can feel surprising or even unsettling. Psychologists note that understanding infinity represents a major cognitive leap because it requires accepting a concept that cannot be fully represented or finished. Throughout history, debates about infinity often reflected broader questions about knowledge itself. Can humans truly understand reality, or are some ideas permanently beyond comprehension? Infinity sits at this boundary. It is understandable enough to be useful, but mysterious enough to resist complete explanation. This dual nature keeps philosophers and scientists engaged with the concept even today. The human idea of infinity also influenced moral and existential thinking. Concepts like infinite responsibility, infinite possibility, or infinite progress appear in philosophy and literature. These uses show how infinity moved beyond numbers into abstract thinking about meaning and purpose. People began to imagine not just endless quantities, but endless improvement, knowledge, or exploration. Importantly, infinity challenges the way humans define existence. Normally, something exists if it occupies space or time. Infinity does neither in a traditional sense. It cannot be pointed to or contained. Instead, it functions as an idea that organizes understanding. This makes infinity different from ordinary objects. It exists conceptually rather than physically, yet its influence on reasoning is undeniable. The development of science gradually transformed humanity's relationship with infinity. Astronomy revealed distances so vast they felt almost infinite. Microscopy revealed tiny structures that could be divided into smaller parts repeatedly. The universe appeared immense, both outward and inward. Humans began to suspect that infinity might appear at both extremes of scale, the very large and the very small. Despite these advances, infinity remains psychologically challenging. People often confuse extremely large quantities with true infinity. For example, billions or trillions feel infinite in everyday language, even though they remain finite numbers. This confusion highlights how human intuition struggles to separate very big from endless. Another reason infinity fascinates humans is that it represents ultimate freedom from limitation. Finite things can be exhausted, completed, or destroyed. Infinite things, by definition, cannot. This gives infinity a symbolic association with perfection and permanence. Philosophers and theologians frequently connected infinity with ultimate truth or absolute reality because it seemed immune to change or decay. At the same time, infinity produces discomfort. If something never ends, can it ever be completed? If time were infinite in the past, how did the present moment arrive? Questions like these show how infinity pushes reasoning into unfamiliar territory. It forces humans to reconsider assumptions about cause, sequence, and existence. The human idea of infinity, therefore, is not a single concept, but a layered development shaped by emotion, culture, philosophy, mathematics, and imagination. It began as awe before nature, evolved into religious symbolism, became a philosophical puzzle, and eventually transformed into a mathematical necessity. Each stage added depth while preserving mystery. Even today, when advanced mathematics handles infinity with precision, the original human experience remains unchanged. Looking at the horizon still feels endless. Thinking about time stretching forever still feels overwhelming. Infinity continues to live simultaneously in logic and emotion, calculation and wonder. This dual existence may explain why infinity has never lost its power to inspire curiosity. It represents both the limits of knowledge and the expansion of thought. By imagining infinity, humans step beyond immediate experience and explore possibilities that cannot be confined by ordinary understanding. The human idea of infinity ultimately reveals something profound about intelligence itself. Humans are capable of forming concepts that exceed direct experience. We can think beyond what we can see, measure, or complete. Infinity is perhaps the clearest example of this ability, a concept born from finite minds reaching toward the limitless. As human civilization progressed, the idea of infinity slowly moved from imagination and philosophy into structured reasoning. While early thinkers sensed infinity emotionally and spiritually, later scholars began asking whether infinity could be understood logically. This shift marked one of the most important intellectual transformations in human history. Infinity was no longer only something mysterious. It became something to analyze, debate, and carefully define. During the classical age of philosophy, thinkers realized that infinity created both clarity and confusion. On one hand, infinity explained continuous processes such as motion, division, and growth. On the other hand, it introduced contradictions that challenged logic itself. Philosophers began distinguishing between two different ways of thinking about infinity. One was infinity as a process that never ends, something always continuing. The other was infinity as a completed total, an actual infinite thing existing all at once. This distinction would shape human understanding for thousands of years. The idea of infinity as a process felt easier to accept. For example, numbers continue forever because you can always add one more. This does not require infinity to exist as an object. It only requires endless continuation. Many philosophers accepted this potential infinity, believing infinity exists only as an ongoing action. However, the idea of actual infinity, meaning something fully infinite, existing, seemed far more troubling. Could something truly contain an infinite number of parts? Could reality itself be infinite defective? These questions became central to debates about nature and existence. If space were infinite, it would have no edge. If time were infinite in the past, events would stretch backward forever. Yet humans struggle to reconcile such ideas with everyday reasoning. The mind prefers beginnings and endings because they create structure. Infinity removes that structure, leaving thought without a final boundary. As mathematical thinking advanced in ancient and medieval periods, infinity gradually became unavoidable. Geometry required understanding lines that extend endlessly. Calculations involving curves and motion hinted at infinite divisions of space and time. Scholars realized that avoiding infinity limited progress. Still, many treated it carefully, describing infinite behavior indirectly rather than claiming infinity itself existed. The rise of scientific thinking brought new urgency to the concept. Scientists studying motion discovered that change often happens continuously rather than in discrete steps. To describe continuous motion accurately, they needed ways to handle infinitely small divisions. This need eventually led to the development of calculus. Calculus allowed mathematicians to analyze processes approaching infinity or zero without ever fully reaching them. Infinity became a practical tool rather than a philosophical threat. This transformation changed humanity's relationship with infinity dramatically. Instead of fearing contradictions, thinkers learned to manage infinity through precise rules. Infinite series could produce finite results. Endless processes could describe real-world motion. The human mind discovered that infinity, when handled carefully, could explain nature more effectively than finite approximations alone. This success also raised deeper questions. If mathematics could describe infinity so accurately, did that mean infinity existed in reality? Or was mathematics simply a language powerful enough to model patterns without guaranteeing their physical existence? This debate continues even today. Some philosophers argue mathematics discovers truths already present in the universe, while others believe it invents useful systems created by human minds. Psychologically, infinity also reshaped humanity's view of knowledge. Before scientific advancement, humans often assumed or sundering. Infinity proved otherwise. It demonstrated that truth could exist beyond intuition. Accepting infinity required intellectual humility, recognizing that reality might operate according to principles that feel strange or counterintuitive. The human idea of infinity also influenced concepts of progress and future possibility. As societies modernized, people began imagining endless improvement in science, technology, and knowledge. The future was no longer seen as repeating cycles alone, but as an open horizon extending indefinitely. Infinity became a metaphor for potential, the belief that discovery might never truly end. Literature and philosophy reflected this change. Writers explored themes of infinite journeys, endless exploration, and boundless imagination. Infinity symbolized freedom from limitation, but also introduced existential questions. If possibilities are infinite, how do humans find meaning? If time stretches endlessly, does any single moment matter? Infinity expanded not only scientific thinking, but also emotional and philosophical reflection. Modern cosmology pushed the human idea of infinity even further. Observations of galaxies revealed a universe far larger than anyone had imagined. The sheer scale challenged comprehension. Distances measured in billions of light years made Earth appear almost insignificant. Some scientists proposed that space might extend infinitely, containing endless regions beyond observation. Others suggested the universe might be finite, but so vast that it appears infinite from a human perspective. This uncertainty highlights a key feature of infinity in human thought. It often appears at the limits of knowledge. Whenever understanding reaches a boundary, infinity emerges as a possibility. It marks the edge between what is known and what lies beyond measurement. In this sense, infinity functions as both an answer and a question. Another development in human understanding came from recognizing that infinity itself might not be singular. Mathematicians discovered that some infinite sets are larger than others. For example, the set of counting numbers is infinite, but the set of all possible decimal numbers contains an even greater form of infinity. This discovery shocked many thinkers because it contradicted the intuition that infinity must be uniform. The human idea of infinity evolved again from a single endless concept into a hierarchy of infinities. This realization forced humanity to accept that infinity behaves according to rules entirely different from finite quantities. Infinite collections could be compared, structured, and analyzed logically. Infinity was no longer chaos. It possessed its own order. The mind learned that even boundlessness could have structure. Despite these advances, infinity remains deeply connected to human limitation. Humans cannot experience infinity directly. Every observation, measurement, and lifespan is finite. Infinity exists primarily in reasoning and imagination. Yet its effects are real because it shapes how humans understand continuity, possibility, and existence itself. The relationship between infinity and human consciousness is particularly significant. Consciousness allows humans to think beyond immediate sensory input. By imagining endless continuation, the mind transcends physical constraints. Infinity demonstrates the unique capacity of human intelligence to conceive ideas that cannot be physically completed. It reveals that thinking is not limited strictly by experience. At the same time, infinity teaches caution. Many scientific theories produce infinite results when they break down. Physicists often interpret infinities in equations as signs that a theory needs improvement. In this way, infinity acts as a warning signal, a reminder that knowledge is incomplete. The human encounter with infinity, therefore, encourages continuous refinement of understanding. Culturally, infinity continues to influence modern life. Digital technology, for example, creates experiences that feel infinite, endless scrolling information, vast online networks, and continuously expanding data. While not truly infinite, these systems mirror humanity's attraction to boundlessness. The concept shapes how people interact with knowledge and communication in the modern era. Philosophically, infinity still raises unresolved questions. Does reality fundamentally contain infinite aspects, or does infinity arise only because human reasoning extends patterns indefinitely? Is infinity discovered or invented? These questions remain open because infinity sits at the intersection of mathematics, physics, and philosophy. Perhaps the most important insight gained from humanity's long engagement with infinity is that the concept reflects both curiosity and limitation. Humans created infinity to describe what lies beyond completion. It represents an attempt to understand existence without final boundaries. At the same time, it reminds us that some ideas may never be fully grasped. The human idea of infinity has heretofore evolved through several stages: emotional awe, religious symbolism, philosophical debate, mathematical formalization, and scientific application. Each stage expanded understanding while preserving mystery. Infinity remains both useful and elusive, precise in equations, yet overwhelming in imagination. Ultimately, infinity reveals a defining feature of humanity, the ability to think beyond limits even while living within them. Feynman and beings created a concept that transcends finiteness itself. Whether infinity truly exists in the universe or only within human reasoning, its impact on thought is undeniable. By exploring infinity, humans explore the boundaries of knowledge, perception, and imagination. The concept continues to challenge assumptions, inspire discovery, and provoke deep reflection about reality and existence. Infinity may never be fully resolved, but its value lies precisely in that uncertainty. It keeps inquiry alive, ensuring that human curiosity, like the idea of infinity itself, continues without end. The relationship between mathematics and reality has always been one of humanity's deepest intellectual mysteries, and nowhere is this relationship more fascinating than in the concept of infinity. Mathematics treats infinity as a precise, structured, and highly useful idea, while physical reality appears to resist the existence of anything truly infinite. Understanding this contrast requires exploring how infinity functions inside mathematical systems and why the physical universe may operate under very different rules. Mathematics is not limited by physical constraints. It is a logical framework built from definitions, symbols, and consistent reasoning. Within this framework, infinity emerges naturally and inevitably. The moment humans began studying numbers carefully, they realized counting never ends. No matter how large a number becomes, doesn't matter how large a number becomes, another number can always be added. This endless continuation is not an assumption, but a logical consequence of how numbers are defined. Infinity, therefore, entered mathematics as a necessary concept rather than an optional one. In mathematics, infinity does not behave like an extremely large number. Instead, it represents unboundedness, the absence of a final limit. This distinction is crucial because infinity cannot be reached through counting. Even if someone counted for billions of years, they would never arrive at infinity. Rather than being a destination, infinity describes a process that continues indefinitely. Mathematicians learn to treat infinity symbolically, allowing them to analyze patterns that extend beyond finite limits. One of the earliest mathematical encounters with infinity appeared in geometry. A straight line is defined mathematically, extends endlessly in both directions. Similarly, between any 2 points on a line, infinitely many additional points exist. This idea challenges intuition because finite distance contains infinite structure. The discovery revealed that infinity could appear not only in enormous scales, but also within tiny intervals. Infinity exists both in expansion and division. As mathematical thinking matured, scholars began formalizing infinite processes. They studied sequences that continue forever and asked whether such sequences could produce meaningful results. Surprisingly, many infinite processes lead to finite outcomes. For example, repeatedly adding smaller and smaller fractions can approach a specific value. This realization showed that infinity could be controlled through logical rules. Infinite steps could describe measurable results. This breakthrough eventually led to the development of limits, a foundational concept in mathematics. Limits allow mathematicians to describe what happens as a quantity approaches infinity without requiring infinity to be completed. By focusing on behavior rather than completion, mathematics successfully incorporated infinity into rigorous reasoning. Calculus, one of humanity's most powerful intellectual achievements, depends entirely on this approach. Through calculus, infinity became essential for describing motion, growth, change, and natural laws. Calculations involving velocity, acceleration, and curved shapes rely on infinitely small divisions of time and space. These divisions are not physically performed but mathematically imagined. Infinity allows continuous processes to be analyzed with extraordinary accuracy. Modern physics, engineering, and technology all depend on mathematical methods involving infinity. However, this success raises an important philosophical question. Does mathematics describe reality exactly, or does it provide models that approximate reality? Mathematical infinity works perfectly within equations, but whether nature itself contains infinity remains uncertain. The difference between mathematical existence and physical existence becomes central to understanding infinity's true status. Mathematics allows ideal objects that may not exist physically. Perfect circles, infinitely thin lines, and exact points have no physical counterparts. Every real object has imperfections and limits. Similarly, infinity might function as an idealization, a concept that simplifies reasoning even if reality itself remains finite. This possibility suggests that infinity belongs to the language of description rather than the structure of the universe. Physics often encounters infinities when theories break down. For example, certain equations predict infinite density or infinite energy under extreme conditions. Scientists usually interpret these results not as proof of real infinities, but as signs that the model is incomplete. When a theory produces infinity, researchers often search for deeper explanations that remove the infinite result. This pattern implies that physical reality may resist true infinities. Another important difference between mathematics and reality lies in measurement. Mathematics operates with exactness, while physical measurement always includes uncertainty. No instrument can measure infinite distance or infinitely small size. Observations always produce finite values. Even the largest measurable quantities remain limited by observational capabilities. This practical limitation suggests that infinity may never be directly observable. The concept of infinity also appears differently, depending on scale. In mathematics, infinity applies equally to numbers, space, and processes. In reality, however, physical laws impose constraints. The speed of light limits how fast information can travel. Quantum mechanics introduces minimum measurable scales. Energy availability restricts physical systems. These limits contrast sharply with mathematics, where no such constraints exist. The universe itself provides a major testing ground for the question of infinity. Cosmologists study whether space extends infinitely or has a finite size. Observations show the universe is extremely large, but they cannot determine whether it is truly infinite. Scientists can only observe a portion of space limited by the age of the universe and the speed of light. Beyond this observable region, conditions remain unknown. If the universe were infinite, It would contain endless galaxies and possibly infinite repetitions of structures. While mathematically possible, such conclusions remain speculative. Alternatively, the universe might be finite yet unbounded, meaning it has no edge but still contains a limited total volume. This possibility demonstrates how reality may imitate infinity without being infinite. Time presents another contrast between mathematics and reality. Mathematically, timelines can extend infinitely into past and future directions. Physical theories, however, suggest time may have begun with a cosmic origin event. If time has a beginning, then past infinity does not exist physically. Whether the future continues forever remains uncertain and depends on cosmic evolution. Mathematics also introduces different sizes of infinity, showing that some infinite sets are larger than others. This discovery revolutionized understanding by revealing that infinity itself has structure. Yet translating these mathematical infinities into physical reality is difficult. It is unclear whether nature could contain different magnitudes of infinity or whether such distinctions exist only in abstract reasoning. The difference between mathematical infinity and physical reality also affects probability and randomness. In mathematics, infinite sequences allow precise statistical predictions. In reality, only finite samples can be observed. Scientists must approximate infinite models using finite data. This gap between theory and observation highlights how infinity often functions as a guiding ideal rather than a measurable entity. Human cognition plays a role in this distinction as well. The brain can follow logical rules indefinitely, imagining endless continuation, but perception remains finite. People experience time moment by moment and space within limited horizons. Infinity becomes accessible intellectually, but not experientially. The separation reinforces the idea that infinity may belong more to thought than to direct reality. Despite these differences, infinity remains indispensable in science. Mathematical infinities allow predictions that match experimental results with extraordinary precision. Engineers design systems using equations involving infinity, and those systems function reliably. This success creates a paradox. Infinity may not physically exist, yet it enables accurate descriptions of physical phenomena. One explanation is that infinity represents an approximation of extreme limits. When systems become very large or very small, treating them as infinite simplifies calculations without significantly affecting accuracy. For example, physicists may treat space as infinite when studying local phenomena because boundaries are too distant to matter practically. Infinity thus becomes a tool for simplification. Philosophers debate whether mathematics discovers truths embedded in reality or constructs useful frameworks invented by humans. If mathematics is discovered, infinity might reflect real features of the universe. If mathematics is invented, infinity might simply be a powerful conceptual tool. The ongoing debate shows how infinity connects deeply to questions about knowledge itself. Another perspective suggests that infinity emerges whenever humans attempt to extend patterns indefinitely. Numbers continue because counting rules allow continuation. Lines extend because geometric definitions permit extension. Infinity arises from the structure of reasoning rather than observation. It represents logical openness rather than physical existence. Even so, the effectiveness of mathematical infinity remains astonishing. Equations involving infinite series accurately describe electromagnetic waves, quantum behavior, and gravitational motion. The universe behaves as though infinity-based mathematics captures genuine aspects of reality. This mysterious effectiveness strengthens the puzzle. Why does an abstract concept work so well in describing the physical world? As human understanding advances, infinity continues to sit at the boundary between abstraction and existence. Mathematics embraces infinity, confidently building entire theories upon it. Reality, however, reveals limits, constraints, and measurable boundaries. The tension between these two perspectives drives ongoing scientific exploration. The comparison between mathematical infinity and physical reality therefore reveals a profound insight. Human knowledge operates through models that may extend beyond direct experience. Infinity allows thinking beyond limits, enabling predictions and explanations that finite reasoning alone could not achieve. At this stage of exploration, infinity stands as both a triumph of mathematical logic and a mystery of physical existence. Whether infinity truly belongs to the universe, or only to the language humans use to describe it, remains unresolved. As the comparison between mathematical infinity and physical reality deepens, modern science reveals an increasingly complex relationship between the two. Mathematics treats infinity as precise and manageable, but physics repeatedly encounters infinity as a warning sign, something that appears when understanding reaches its limits. This contrast has shaped some of the most important discoveries in modern science and continues to influence how humans interpret the universe. In advanced physics, infinity often emerges inside equations describing extreme conditions. For instance, when scientists calculate gravitational collapse using classical theories, the equations may predict infinite density at a single point. Such results do not mean scientists believe infinite density physically exists. Instead, they interpret these infinities as signals that the theory being used is incomplete. When infinity appears, it often indicates that new physics is required. This pattern is repeated throughout scientific history. Early models of heat, light, and atomic structure sometimes produced infinite predictions that contradicted observation. Each time, resolving these infinities led to revolutionary breakthroughs. Quantum mechanics, for example, replaced older ideas, partly because classical physics failed at very small scales, producing unrealistic infinite outcomes. Infinity thus acts like a boundary marker, showing where current knowledge stops working. Quantum theory introduces an especially interesting perspective. At extremely small scales, nature appears discrete rather than continuous. Energy, matter, and even certain properties of space behave in quantized units. This discreteness challenges the mathematical assumption that division can continue infinitely. If reality has smallest possible units, then physical infinity may not exist at microscopic levels, even though mathematics allows endless division. Similarly, theories of space and time suggest there may be fundamental limits to measurement. Some physicists propose a minimum meaningful length and time interval. Below these scales, the concept of distance itself may lose meaning. If true, this would mean reality prevents infinite subdivision, directly contrasting with mathematical models that permit infinite detail within any region. Cosmology presents another arena where infinity becomes both tempting and uncertain. Observations show the universe expanding, and measurements suggest space may be flat on large scales. The flat universe could be infinite, extending forever without edges. However, observational evidence cannot confirm infinity directly because humans can only observe a finite region limited by light's travel time. The observable universe may represent only a small portion of a much larger reality. Scientists therefore distinguish between observable infinity and theoretical infinity. Observable infinity would require direct evidence of endless extent, which remains impossible with current methods. Theoretical infinity arises from known models consistent with known laws. These models allow infinite space, but allowance is not proof. Infinity remains a possibility rather than a confirmed feature of nature. The idea of infinite time raises equally complex questions. Mathematics allows timelines stretching endlessly into both past and future directions. Physical cosmology, however, suggests time may have begun with a cosmic origin event. If time has a beginning, then past infinity does not exist physically. The future might continue indefinitely, but whether it becomes truly infinite depends on cosmic evolution, energy distribution, and physical laws that are still being studied. Another major difference between mathematics and reality appears in energy and resources. Mathematical systems can contain infinite elements without cost. Physical systems require energy, space, and matter. Maintaining infinite physical structures would demand infinite resources, which conflicts with conservation laws observed in nature. This practical constraint makes actual infinities difficult to reconcile with physical reality. Probability theory also highlights the contrast. Mathematical probability, often assumes infinite trials or infinite sample spaces to produce clean results. Real experiments, however, involve finite observations. Scientists rely on approximations, using large numbers to simulate infinity. The success of these approximations suggests infinity functions as an ideal limit rather than a literal condition. One of the most surprising developments in mathematics was the discovery that infinities themselves can differ in size. Some infinite sets can be placed into one-to-one correspondence with smaller subsets, while others cannot. This structured hierarchy of infinities demonstrates how mathematics can explore realms far removed from physical intuition. Yet no evidence currently shows that physical reality contains multiple sizes of infinity. The distinction may remain purely conceptual. The effectiveness of mathematical infinity in describing nature remains one of the deepest philosophical puzzles. Mathematical equations involving infinite series accurately predict physical phenomena such as electromagnetic radiation and quantum interactions. Engineers rely on these equations to design technologies that function reliably in the real world. This success raises an important question: why should abstract infinities correspond so closely to observable behavior? One explanation is that infinity represents the endpoint of patterns. Physical processes may approach certain behaviors so closely that treating them as infinite produces accurate predictions. For example, a wave may oscillate for such a long duration that modeling it as endless simplifies analysis without introducing meaningful error. Infinity becomes a useful approximation of extreme continuity. Another perspective argues that mathematics reveals underlying structures of reality rather than merely describing them. According to this view, infinity might exist fundamentally even if humans cannot observe it directly. The universe may contain properties that only appear infinite when viewed through mathematical reasoning. Reality could possess deeper layers accessible only through abstraction. Opposing views suggest infinity arises because human reasoning extends rules indefinitely. When patterns appear consistent, the mind assumes continuation without end. Infinity becomes a logical extension rather than an empirical discovery. Under this interpretation, infinity belongs to thought systems rather than physical existence. The debate between these perspectives remains unresolved because infinity cannot be experimentally verified. Science depends on observation, yet infinity lies beyond observation by definition. No measurement can confirm endlessness. Scientists, therefore, rely on indirect reasoning, examining whether theories requiring infinity produce accurate predictions. Modern theoretical physics continues struggling with infinities. Attempts to unify gravity with quantum mechanics often produce mathematical infinities that must be removed through specialized techniques. These procedures allow calculations to work, but leave open questions about whether infinities represent real aspects of nature or artifacts of imperfect models. Interestingly, some modern approaches attempt to eliminate infinity entirely from fundamental physics. Certain theories propose that the universe operates through finite informational structures, suggesting reality may ultimately be discrete rather than continuous. If such theories prove correct, infinity might disappear from fundamental descriptions of nature while remaining useful at larger scales. The relationship between infinity and reality also influences philosophical discussions about existence. If the universe were infinite, every physically possible arrangement of matter might occur somewhere. This idea leads to profound implications about repetition, identity, and probability. However, because infinity cannot be confirmed observationally, these implications remain speculative. Human psychology plays an important role in the persistence of infinity as a concept. Infinity satisfies curiosity about what lies beyond limits. Whenever humans encounter boundaries, spatial, temporal, or intellectual, infinity provides a way to imagine continuation. It transforms unknown regions into conceptual extensions rather than absolute endings. Technological progress reinforces this tendency. Data networks, expanding knowledge bases, and continuous streams of information create experiences that feel infinite, even though they remain finite in St. Mener, Rupture, Modern life increasingly mirrors the abstract qualities of infinity, strengthening its presence in human thinking. Despite centuries of study, the tension between mathematical infinity and physical reality remains unresolved. Mathematics demonstrates that infinity can exist logically without contradiction when defined carefully. Physics shows that observable phenomena always appear finite and measurable. The two perspectives coexist, each valid within its own domain. This coexistence may represent a deeper truth about knowledge itself. Mathematics explores what is logically possible, while science investigates what is physically actual. Infinity belongs fully to the realm of possibility, but only partially, if at all, to the realm of physical existence. Understanding this distinction helps explain why infinity feels both certain and mysterious at the same time. Ultimately, infinity in mathematics serves as a powerful language for describing patterns without limits. In reality, however, nature may impose boundaries that prevent true infinity from manifesting physically. The success of infinite mathematics does not necessarily prove infinite reality, yet it reveals how abstract reasoning can illuminate the structure of the world. The comparison between mathematics and reality therefore teaches an important lesson. Human understanding operates through idealized concepts that extend beyond direct experience. Infinity stands as one of the greatest examples of this ability, a concept perfectly clear in logic, yet forever uncertain in existence. By examining infinity through both mathematical precision and physical investigation, humanity continues exploring the boundary between imagination and reality. Whether infinity ultimately proves to be a fundamental feature of the universe or a remarkable invention of human reasoning, its role in shaping knowledge is undeniable. It remains a bridge between abstract thought and empirical discovery, inviting continuous inquiry into the deepest nature of existence. Infinity becomes truly fascinating and deeply confusing when it produces paradoxes. A paradox is a situation where logical reasoning leads to conclusions that seem impossible or contradictory. The paradoxes of infinity have challenged philosophers, mathematicians, and scientists for thousands of years because they reveal how human intuition breaks down when dealing with endless quantities. These paradoxes are not simply puzzles. They expose fundamental limits in how humans understand reality, logic, and quantity. One of the main reasons infinity creates paradoxes is that human thinking evolved to handle finite experiences. Everyday life involves counting objects, measuring distances, and observing events that have beginnings and endings. Infinity removes these familiar boundaries. When something has no limit, many rules that apply to ordinary numbers stop working. As a result, reasoning that seems perfectly logical can produce outcomes that feel absurd. A classic paradox arises from the idea of dividing space infinitely. Imagine walking toward a destination. Before reaching it, you must travel half the distance. After that, you must travel half of the remaining distance, then half again, and so on forever. Logically, this creates an infinite number of steps. If completing infinitely many steps were required, it would seem impossible to ever arrive. Yet in real life, people clearly reach their destinations. The paradox reveals a conflict between infinite logical division and physical motion. The resolution lies in understanding that infinite processes can produce finite results. Each step becomes smaller and smaller, and the total distance covered adds up to a finite amount. Mathematics shows that infinitely many decree, as in quantities can sum to a limited value. This discovery was revolutionary because it demonstrated that infinity does not always behave as endless accumulation. Sometimes it converges toward completion. Another famous paradox involves infinite collections. Consider a hotel with infinitely many rooms, all occupied. In ordinary thinking, a full hotel cannot accept new guests. However, if the hotel has infinitely many rooms numbered 1, 2, 3, and so on, every guest could move from their current room to the next higher number. Room 1 becomes empty, allowing a new guest to enter. Even more surprisingly, infinitely many new guests could be accommodated by shifting occupants in specific patterns. The paradox shows that infinite sets can grow without becoming larger in the usual sense. This challenges the intuition that adding more items must increase size. In infinite systems, a part can be equal in size to the whole. For example, the set of all even numbers seems smaller than the set of all counting numbers, yet both contain infinitely many elements and can be paired one to one. Infinity breaks the rule that wholes must be larger than their parts, forcing mathematicians to redefine how size is understood. Paradoxes also appear when infinity interacts with time. Imagine an infinite past stretching endlessly backward. If infinitely many moments occurred before now, how did the present moment arrive? It seems impossible to complete an infinite sequence of events to reach today. This paradox raises questions about whether time could truly be infinite in the past. Philosophers continue debating whether an infinite history is logically possible or whether time must have a beginning. Another paradox emerges from probability. Suppose a dart is thrown randomly at a line containing infinitely many points. The probability of hitting any specific point is effectively zero because, say, there are infinitely many possibilities, yet the dart must land somewhere. How can an event with zero probability still occur? This paradox demonstrates how probability behaves differently when infinity is involved, requiring careful mathematical interpretation. Infinity also creates paradoxes related to measurement and physical reality. If matter could be divided infinitely, objects would contain endless internal structure. However, modern physics suggests limits to divisibility, indicating that infinite division may exist mathematically but not physically. This difference highlights how paradoxes often arise when abstract infinity is applied directly to the real world. One of the deepest paradoxes concerns infinite repetition. If the universe were infinite in size and matter arranged in limited ways, then every possible configuration might occur infinitely many times. Somewhere in an infinite cosmos, exact copies of events, or even individuals, could exist. While logically consistent, this idea feels unsettling because it challenges concepts of uniqueness and identity. Paradoxes of infinity also influence the development of modern mathematics. Early thinkers treated infinity cautiously because paradoxes seemed to threaten logical consistency. Over time, mathematicians created precise definitions and rules that allowed infinity to be handled safely. Set theory and modern logic showed that many paradoxes arise not from infinity itself, but from unclear assumptions. By defining terms carefully, contradictions could often be resolved. Despite these solutions, infinity still produces philosophical puzzles that remain unresolved. Some paradoxes suggest that human intuition may simply be unreliable when dealing with infinite concepts. Others imply that infinity reveals genuine features of reality that cannot be understood using ordinary reasoning. Psychologically, paradoxes serve an important role. They force people to question assumptions that normally go unnoticed. For instance, humans instinctively believe that adding always increases size, or that completing infinite tasks is impossible. Infinity challenges these beliefs, expanding the boundaries of thought. In this way, paradoxes act as tools for intellectual growth. Scientific progress has repeatedly emerged from confronting paradoxes. When theories produce contradictions involving infinity, scientists search for deeper explanations. Quantum mechanics and relativity both developed partly because earlier models failed under extreme conditions. Infinity-driven paradoxes therefore guide discovery by revealing weaknesses in existing understanding. Philosophically, the paradoxes of infinite things suggest that reality may not align perfectly with human intuition. The universe might operate according to principles that feel strange because they lie beyond everyday experience. Infinity exposes the gap between logical possibility and intuitive expectation. Ultimately, the paradoxes of infinity teach an important lesson. Infinity is not merely a larger version of finiteness. It follows its own rules, reshaping ideas about size, motion, probability, and existence. What seems impossible at first often becomes understandable through deeper reasoning. Rather than proving infinity impossible, these paradoxes reveal its complexity. They show that infinity challenges the mind precisely because it stretches reasoning beyond familiar limits. By grappling with infinite paradoxes, humans learn not only about mathematics and physics, but also about the nature of understanding itself. Infinity's paradoxes remain powerful reminders that knowledge advances when assumptions are questioned. They invite continuous exploration, ensuring that the study of infinity remains one of humanity's most profound intellectual journeys. The idea of infinity becomes especially powerful when humans look outward into space. The universe appears unimaginably vast, filled with billions of galaxies, each containing billions of stars. This overwhelming scale naturally leads to one of humanity's greatest questions. Is the universe infinite, or is it simply extremely large, but still finite? Exploring infinity in space connects astronomy, physics, philosophy, and human curiosity because it challenges how we understand reality itself. For most of human history, people assumed the universe was relatively small. Ancient civilizations imagined the stars fixed on a celestial sphere surrounding Earth. The cosmos seemed ordered and limited. However, scientific discoveries gradually expanded humanity's cosmic perspective. Telescopes revealed that stars were distant suns, galaxies existed far beyond our own, and space extended much farther than anyone had imagined. Each discovery pushed the apparent boundary of the universe farther away, making infinity seem increasingly plausible. Modern astronomy shows that the observable universe is enormous. Light travels at a finite speed, meaning we can only see objects whose light has had time to reach us since the beginning of cosmic expansion. This visible region is called the observable universe. Beyond it may lie vast regions we cannot see, possibly extending forever. The key point is that observable limits do not necessarily represent actual limits. The universe could continue far beyond what humans can detect. Scientists use geometry to study whether space might be infinite. According to modern cosmology, the large-scale structure of space can be curved, flat, or closed. If space has positive curvature, it would resemble the surface of a sphere, finite but without edges. Traveling far enough in one direction could eventually bring you back to your starting point. If space is flat, however, it could extend infinitely in all directions. Current observations suggest the universe is very close to flat, which keeps the possibility of infinity open. Understanding infinite space requires separating intuition from physics. Humans often imagine infinity as endless emptiness, but physical infinity would mean infinitely many galaxies, stars, and potentially planets. In such a universe, matter would not simply stop somewhere. Space would continue without boundary. This idea challenges human perception because we are accustomed to edges and borders. Everything in daily life exists within limits, making an edgeless universe difficult to imagine. One important consequence of an infinite universe involves repetition. If space were truly infinite and the laws of physics remain consistent everywhere, then matter could arrange itself in every possible configuration somewhere. Given infinite opportunities, even extremely unlikely arrangements might occur repeatedly. This leads to the astonishing possibility that distant regions of space could contain environments identical to ours. While this idea arises logically from infinity, it remains speculative because infinity itself has not been confirmed. The expansion of the universe adds another layer to the discussion. Observations show that galaxies are moving away from each other as space expands. This expansion does not mean galaxies are flying into empty space. Instead, space itself is stretching. A helpful analogy is dots drawn on a balloon's surface, moving apart as the balloon inflates. The surface expands without needing an external space into which it grows. Similarly, the universe may expand without expanding into anything. This raises a profound question. If the universe is expanding, must it be infinite? Surprisingly, expansion does not automatically imply infinity. A finite universe can expand just as a balloon's surface grows larger while remaining limited in area. Therefore, expansion alone cannot determine whether the universe is infinite or finite. Scientists must rely on measurements of cosmic background radiation, galaxy distribution, and gravitational effects to infer cosmic geometry. Another factor influencing the idea of infinity in space is cosmic horizon limits. Because light travels at a fixed speed, there are regions of space from which light has not yet reached Earth. These regions are permanently beyond observation if expansion continues accelerating. Even if the universe were infinite, humans could never observe all of it. Infinity, therefore, may exist beyond observational reach, making it scientifically difficult to confirm. The concept of infinity also appears in discussions about the multiverse. Some theoretical models suggest our universe might be one region within a much larger cosmic structure. In certain models, new regions of space continuously form, potentially creating an endless collection of universes. While intriguing, these ideas remain theoretical and currently lack direct observational evidence. They illustrate how infinity often emerges when scientific theories explore extreme possibilities. Physics also raises questions about whether true physical infinity is even allowed. Some scientists suspect nature avoids infinities because they create problems in equations and predictions. If physical laws impose limits, such as maximum energy density or minimum measurable length, then the universe might ultimately be finite, even if enormously large. Infinity might appear only in mathematical descriptions rather than in physical existence. Human psychology plays a strong role in how infinity in space is perceived. When people look at the night sky, the vastness creates a feeling of boundlessness. This emotional experience can make infinity feel obvious, even though scientific evidence remains uncertain. The difference between emotional perception and empirical proof highlights how infinity occupies both scientific and philosophical territory. Infinity in space also changes humanity's sense of importance and position in the cosmos. In a finite universe, humanity might occupy a unique location within a limited system. In an infinite universe, however, Earth becomes one small point among endless possibilities. This perspective can feel humbling, but also liberating, emphasizing that existence may not revolve around any single place or observer. Another interesting implication involves time and exploration. Even if space were infinite, humans could only explore a finite portion due to physical limitations such as energy, lifespan, and cosmic expansion. Infinity would remain forever beyond direct experience. This reinforces the idea that infinity may exist conceptually even if it remains practically unreachable. Scientific investigation continues seeking clues about cosmic size and structure. Advanced telescopes and space missions analyze faint radiation left over from the early universe to understand its geometry. Each new measurement refines estimates but has not yet resolved whether space is infinite. The question remains open because confirming infinity requires evidence that extends beyond any finite observation. Philosophically, infinity in space forces humans to reconsider what it means for something to exist. If something extends endlessly beyond observation, can it be said to exist in the same way as observable objects? Science generally accepts models that best explain available evidence, even they include unobservable regions. Infinity thus becomes part of scientific reasoning without necessarily becoming directly testable. Ultimately, infinity in space and the universe represents one of humanity's deepest unanswered questions. Mathematics allows infinite space easily, while physics cautiously examines whether reality truly permits it. Observations suggest the universe is vast beyond imagination, but whether that vastness becomes true infinity remains unknown. The exploration of cosmic infinity reveals both the power and the limits of human understanding. By studying the universe, humans attempt to measure something that may have no end. Whether the cosmos is infinite or simply unimaginably large, the search itself expands knowledge and deepens appreciation for the mystery of existence. Infinity in space reminds us that the universe may extend far beyond perception and perhaps beyond comprehension, encouraging continual curiosity about the nature of reality and humanity's place within it. The concept of infinity becomes especially profound when applied to time. While spatial infinity asks whether the universe stretches endlessly outward, Temporal infinity asks whether time itself has no beginning or no end. Humans naturally experience time as a continuous flow, moments passing one after another, which makes it easy to imagine time continuing forever. However, when examined scientifically and philosophically, the idea of infinite time becomes far more complex. From a human perspective, time feels endless because each moment leads naturally into the next. There is always a tomorrow after today, just as there was a yesterday before it. This continuity encourages the intuitive belief that time may extend infinitely in both directions. Ancient cultures often imagined eternal cycles of creation and destruction, suggesting that the universe had always existed and would continue forever. Eternity became closely connected with ideas of permanence and immortality. Philosophers later questioned whether an infinite past could truly exist. If time stretched infinitely backward, it would mean an endless number of events occurred before the present moment. This raises a paradox. How could the present ever arrive if infinite? The final question surrounding infinity is perhaps the most philosophical of all. Does infinity actually exist in reality, or is it simply a powerful idea created by the human mind to understand the universe? After exploring infinity through mathematics, physics, space, time, and scientific limits, this question brings together all perspectives into one central debate about the nature of existence and knowledge. In mathematics, infinity is unquestionably real within its own system. Mathematical rules allow infinite numbers, infinite sequences, and infinite structures to exist logically without contradiction. Mathematicians work with infinity precisely and consistently, proving theorems and solving problems that depend on infinite concepts. From this viewpoint, infinity is not imaginary. It is a well-defined element of mathematical reality. However, mathematical existence does not automatically mean physical existence. Physical reality operates differently from abstract reasoning. Science depends on observation and measurement, and every observed phenomenon so far appears finite. Distances, energies, lifetimes, and measurable quantities always produce limited values. Even when something seems endless, such as the vastness of space, scientists cannot confirm that it truly has no boundary. This creates uncertainty about whether infinity exists outside mathematical descriptions. One perspective argues that infinity is a useful conceptual tool rather than a physical feature. According to this view, humans invented infinity to describe processes that continue indefinitely or exceed practical limits. Instead of saying something is infinitely large, scientists often mean it is so large that boundaries do not affect the calculation. Infinity simplifies equations and helps predict behavior without requiring literal endlessness. Another viewpoint suggests that infinity may exist fundamentally even if humans cannot observe it directly. Just as microscopic particles were once invisible but later confirmed, infinity might represent a deeper aspect of reality beyond current observational capability. Supporters of this idea argue that the success of mathematical models involving infinity hints that nature itself may contain infinite properties. A middle position proposes that infinity exists as a limit rather than an object. In this interpretation, infinity describes what happens when processes continue without stopping, not a completed state. For example, numbers increase endlessly, but infinity itself is never reached. Reality may contain endless potential without containing actual infinite quantities. Human cognition plays an important role in this debate. The mind naturally extends patterns beyond experience, imagining continuation without end. Infinity may arise from this ability to generalize rules indefinitely. It reflects the structure of human reasoning as much as the structure of the universe. In this sense, infinity reveals how humans think rather than what physically exists. Philosophically, the question also touches on the nature of truth. Some truths exist independently of observation, while others depend on human definitions. Infinity sits at this intersection. It is undeniably true within mathematics, possibly true in physical reality, and psychologically real in human imagination. Its status changes depending on the domain in which it is considered. Ultimately, whether infinity is real or merely useful may never receive a final answer. Science may continue approaching the question without resolving it completely, because proving infinity requires evidence beyond finite observation. Yet the importance of infinity does not depend on certainty. Its value lies in expanding thought, guiding scientific models, and challenging assumptions about limits. Infinity, therefore, stands as both a discovery and an invention, a bridge between logic and reality. Whether it exists physically or only conceptually, it remains one of humanity's most profound ideas, pushing understanding beyond boundaries and reminding us that some questions may remain forever open.